In this example, we're going to go ahead and solve this rational equation. So when we're looking at rational equations, there's a lot we have to keep in mind. First, we have to keep in mind the domain, like where can x not equal. So in this example, we have this x minus 5 in the denominator, x plus 5 in the denominator, and then we also have this x squared minus 25 in the denominator. So what that means is that we have to find all the values that x cannot equal to 0 out the denominator. So what values would 0 out x minus 5, what values would 0 out x plus 5, and so on. Before we even do that, though, we need to factor this term because we have to keep everything in mind, all denominators in mind. So I'm going to, let's just rewrite this for now. So 3 over x minus 5 plus 2 over x plus 5 equals 4 over, and then this is going to be a difference of two squares. So x minus 5 and x plus 5, just factoring a difference of two squares there. X squared is a perfect square, 25 is a perfect square, so x minus 5, x plus 5. So that means that we have this x minus 5 and x plus 5, and those are the same. So x cannot equal 5, because if we take x minus 5, set it equal to 0, we get x equal to 5, so x cannot equal 5. And then if we were to take x plus 5, set it equal to 0, and then we solve for x there, x equals negative 5, so x cannot equal 5. And x cannot equal negative 5. So those are the two values that are going to zero out our denominator. So what that means, though, in terms of what we're doing here, when we go down to the end and we get x is equal to something, if it's equal to 5, then we can't call that one of our solutions because x cannot equal 5 and x cannot equal negative 5. So it just kind of depends on what we get down to our solution. All right, so now we want to start to solve this. In order to solve for x, we need to multiply by a least common denominator. So we just take all of our denominators, so x minus 5, x plus 5, x minus 5 times x plus 5. So our least common denominator is going to be x minus 5 times x plus 5. Because these are this x minus 5, x minus 5, x plus 5, x plus 5. So I don't need to like multiply by multiple x minus 5s or anything like that. We just need to multiply by an x minus 5 and x plus 5. So now we're going to multiply everything by that LCD. So I'm going to multiply this side by x minus 5 times x plus 5. I'm going to multiply this side by that x minus 5 times x plus 5. And here's the goal of why we are multiplying by the LCD. Here's what we want to have happen. We want these denominators to be gone. So then we're going to be left with just a equation, like a two-step, three-step, multiple step, maybe equation. Like that's our whole goal. So that way we're not having to multiply anymore or do any sort of weird manipulation. We just want to wipe out these denominators. So when I perform this, I'm going to multiply this whole term by 3 over x minus 5. I'm going to multiply this whole term times 2 over x plus 5. A very common mistake that I see when trying to teach this concept is we'll do this multiplication of x minus 5 times x plus 5 times 3 over x minus 5. And you'll notice, like, all right, I have x minus 5s. Those are going to cancel. But then we'll forget this x minus 5 over to this term. So you want to do x minus 5 times x plus 5 times this, x minus 5 times x plus 5 times this. So this LCD needs to be multiplied to all terms. Same thing over here. So just to show you exactly what I mean by that, we have 3 times x minus 5 times x plus 5 over x minus 5 plus 2 times x minus 5 times x plus 5 over x plus 5. And this is kind of dragging it on a little bit longer than it needs to be. Like you could just more mentally just make the cancellation, but just to show you the full process here. Then I'm not going to rewrite over here because what's going to happen over here, since we just have 4 over x minus 5, x plus 5, so 4 over the LCD, x minus 5s are going to cancel, x plus 5s are going to cancel, so we're just left with 4 over there. But on this side, there's a little bit of some work that needs to be done because on here, x minus 5s are going to cancel out, leaving us with a 3 times x plus 5. Plus, and then the x plus 5s are going to cancel out there, leaving us with 2 times x minus 5. So it's not as nice as the right side of the equation where the least common denominator completely wipes out there and just leaves us with 4. But nothing too difficult. We just want to now distribute the 3 into here, distribute the 2 into here. So we're going to have 3 times x is 3x 3 times 5 is going to be 15, plus 2 times x is 2x, 2 times negative 5 is negative 10, equal to 4. Then we just have some solving to do. So multi-step equation, like I said, that's the whole goal. We want our denominators to wipe out, leaving us with a very manageable multi-step equation. So we're going to have 3x plus 2x. Move me up here. So 3x plus 2x is 5x. And then 15 minus 10. 15 minus 10 is 5. Equals 4. Then I'm going to solve for x by subtracting 5 on both sides. We're solving a two-step equation now. So 5x equals 4 minus 5 is negative 1. Solve a one-step equation, divide by 5, and x equals negative 1/5. So don't just circle this, move on. Double check what was our domain. Like what values can we not have? So the domain was all reals besides 5 and negative 5. So that means my answer of x equals negative 1/5, it's fine. It's close to negative 5, but it's not quite. It's negative 1/5, negative 5 we cannot have, but we can have negative 1/5. So x equals negative 1/5 would be our answer. So that's how we would go about solving this rational equation.